So here's our Super Pro light, and it's very similar to the bench mill, except the bench mill is enclosed. This one has a little bit beefier spindle, so the spindle is bigger. It just looks a little bit bigger on the outside, but that's really the only difference. Once you get your Super Pro light, or once you get your Intellitek mill, or any mill for that matter, you have to consider some things like what are you going to use to clamp material into the machine. Here's a really poor example, but a very cheap example. It doesn't work the best, but for what I do, if you take a look, it's nothing but a drill press vise. And this was about, I think, $58 when I bought it at Enco, and there's a link to it on the website, but you can check it out. It works for everything that we do. The only downside is that this jaw lifts up once in a while. All I have to do is undo my strap clamps, and there's a bolt underneath, a hex screw underneath that will allow me to tighten that up so that it doesn't lift up like that as much. But it will always lift because of the type of mechanism that it is. And this one is really, really nice, really heavy duty, rock solid. It will clamp. It will not turn. Your stock can go in there beautifully. It's all metal. It weighs about 20 pounds, solid steel. And when notice that this does not move at all, it'll be perfectly square every time. If you're doing crazy accurate work, this works great. It'll work with your yo-yo too, because I know, like Ryan, his yo-yos are so accurate, it's unbelievable. My yo-yos really aren't that accurate. So I just bought this because I wanted to try it in there. You got to be careful. The downside to using vise on the Intellitek machines is they have a pretty small bed.
The other thing that
So if you notice,
yeah, if I could just add something there as well, especially if you are very new to this whole process,
4 to 5 inches long.
Just to be honest with you, like the accuracy of your parts is going to be inaccurate for a little while until you get your bearings on everything. And where Chris is showing you his drill press vise, which is in the machine right now, that thing was $58 versus his machinist vise, which is not in the machine right now, was probably like, I don't know, $200, something in and around there. If you hit the vise with the end mill, it's going to leave a gouge in there. So $58 with a gouge in it is a lot easier to stomach than $200 with a gouge in it.
Yeah, and I got to be honest. It's for everything that the containers, we're accurate on the containers to 0.02 of an inch, and this, if you design it right, this thing works just fine. Like I said, though, I'm going to try that other one. I'm going to throw that one in here because it fits. The downside to this is that this handle, if you notice, there's a mysterious cutout on the front of my safety shield where this sticks through here, and then when the vise is turned this way, I can clamp things that are 4 inches wide by infinity long. Well, infinity being 10 inches in this machine. So that just gives me a little more room if I go the other way with it. And that leads you to, well, how do you put the vise?
We were talking about accuracy there and how, inaccurate or accurate your parts are going to be. And you threw out the number 0.02 of an inch. When we're saying something's inaccurate, we're talking about something that's out by maybe 0.010 or more, which is nothing, right? When you're making these parts with kids in high school, we're not making aircraft parts here.
Right.
We're just making stuff for them to get experience. So don't think that you're going to be like a half inch off because of this type of vise. It's
the next step is
if you
to
check it with a caliper, it's going to be a little bit further out.
And that's where an inexpensive set of machinist squares comes in handy. You can see this one has gotten a little rusty. That's really no good. Keep a thin coat of oil on all of these parts and it'll keep everything in really good shape. But you can use your machinist square and you can set up your your vise on the table. And I got to be honest with you, I cheated on this machine. If you look, this machine does not have a T-slot. This is the lamest setup I have ever seen in my life when it comes to a milling machine. Usually they have T-slots, and then you have to square up the vise this way and square up the vise with a bigger square this way, and then clamp them with, and these actually, the strap clamps are actually, if your bed were bigger, these are made to go down here and clamp in this groove along the front edge or the two sides. There's not enough room here, so I had to improvise and put clamps out here. Just know that when you start adding clamps up here in the air, you got to be very careful. Your tool's right here, right? And you want to make sure that the kids stay away from places where those clamps might be. So these are called strap clamps, and they hold the vise in place. This setup will stay here. I've done my yo-yos in this. We do our CNC initials on this. The flange that we're going to do tonight, we do on this. The containers we do on this. So every project I do, I set this up and it's done. It's there for the year. I can show you, if you do have a Pro Light, and I know some of you have a Super Pro Light, if you have this lame bed that has set screws in it, if you take a close-up look, you can see what I did was I took this set screw, stuck it up in the air, and I did the same thing in the back, one here and one here, and that's how I squared up my vise, because these holes, these hole patterns are square. So that's how I squared up my vise on that table. A little method of cheating. I didn't even have to use my my Machinist square set, but on any other table that you have a T-slot set, you have to. And that leads you to, okay, so where do you get, things like this? If I remember, I will put a link to that. If it's not in, I think there's one in the purchase manual, but here's an example of the set that I had to buy for that. And I bought this at Enco, and I think it was a total of $80. And it comes with all the different size straps, all the different size. And most of the stuff is too big for this machine, but it does come with some of the parts that will make it work. And it also comes with the T-slot set, so that this will work on my Pro Light, or it'll work on any other machine like the bench mill that has the T-slot set. So it comes with T-slot nuts, so that if you have the right set, and again, it's about $100 between $80 and $120 for the import version.
I just quickly want to point out,
plenty accurate for what you want.
Enco, just so everybody knows, and I tossed it in the chat window so you have it. But Enco was bought out by MSC Direct.
Sure.
So I'm going to put that in there, and in a minute I'll pull up some of the parts that Chris is showing you, and I'll try to put them in the chat window as he's showing them off to you.
All right, so let's say you've decided on your vise. You have your vise. You've got your strap clamp set. You put your vise in with your strap clamps. It's mounted on the table. It's permanent pretty much. It's there. It's ready to go. The next thing you have to do is put your stock in the vise. And notice that there's a fixed side of the vise and a not fixed side. So you always want to make the fixed corner of your vise PRZ. If I had... I think I'm going to do it this year. I'm going to actually tap a hole in the side of this and put a piece of bar stock here so that I can index this every single time straight up in that corner. But what I do now is I use a parallel. This is a fancy parallel. I made this on my laser cutter. It's a piece of acrylic. And when the kids come over here and they put their part in the machine, they put it up against that, hold it down, and then tighten it. And then that front corner is my PRZ, my part reference 0. We'll talk a little bit more about that in a second. The only problem is when I go to touch my tool off on that corner, it's inside my vise. My vise is in the way, and that's no good. I don't ever want my kids machining anywhere near my vise. And I know I'm going to knock on some wood that I don't have a ding in this vise, and this vise is about 7 years old. I know I just cursed myself. It's no big deal. But the way that you do it is you use what are called parallels. And here's a set of parallels that I made on my laser cutter. I made a set of these going up from a 1/4 of an inch right on up to an inch. And they're just acrylic that's been laser cut on the milling machine. Those of you that are machinists are cringing right now because those aren't accurate at all. But they're accurate enough for me to make all the fancy projects that I do in my sim class. If I were a machinist shop or I were teaching kids to be machinists, I would most definitely get a real set of parallels. And so that's how my kids put their material into the vise. So if you take a look over here, I also picked up, I've got a bunch of other different types. Here's what real parallels look like. And these are machined on the top and the bottom edges. So these are super duper accurate. And these are 1/8 by 1 1/8. And you take these, you put them in the vise on either side, and you set your material on top of that, and it's guaranteed parallel. Here's my, and these come in a fancy case. So when you make them like this, you can get them in this nice fancy Ziploc baggie. The baggie costs a little extra, but you know, nothing but the best for my guys. I also have these magnetic parallels. These are aluminum. I've had these forever, and I have a hard time finding these again. But Ryan said he's made some. He's taken his steel ones and actually put a cut in the back and then put neodymium magnets right in the back of those so that he makes his own magnetic parallels. And then what that does for him is that allows those parallels to stick right inside, right up against the jaws of the vise. So they always move with the vise. These, they tend to move around a little bit. But I'm not too worried about it because we are making a government subsidized part tonight. Top secret too, by the way, so you really can't talk too much about this. We're going to make the flange. And so I've got my stock. I'm going to make my flange out of, and I held it down and used a parallel so that this corner is right there. And it's in my machine ready to go, really. There's a couple other things that you have to do. And the first thing is home the machine. And Ryan, if you would show them on your screen where the home button is, in the software, up on the top, there's a picture of a little house, and Ryan's pointing to it on his screen. You probably can't see it on my screen, but it's the exact same thing. That home button, when you click on that, what will happen is your machine will go up in the Z. You'll hear a little click where it hits the top upper limit, and then it'll come off that limit. It'll do it one more time. It'll do it in the X-axis, click, and then it'll do it in the Y-axis, click. And what that does is that homing machine tells the tool, okay, these are your limits. Your limits are here, here, and here. So it tells you what your work envelope is. That's what home does. So the first thing you do after you put your stock in is you find home. You have to find home. The next thing you do is you have to tell it where the corner of the stock is, which is right there. But before we even do that, I want to back up one more step because I have a whole tool library that I'd like to show you. And this is only a portion of Project Lead the Way's tool library. So if you take a look at this, I have in my machine, I have tool number 2. So I'm going to take this out and put it in here so you can see them all. I have tool number 1, 2, 3, 4, 5, 6, 7, 8. And there's a picture of that I put in the chat window that when you go in, you have to set up your tool library. And this is pretty important because the tool library in Inventor, HSM, and CNCmotion, and your actual milling machine all have to be exactly the same. And to do that, we've already showed you how to do that on HSM, We're now going to show you how to do that on the CNC machine and how to do it in CNCmotion. So that when a kid calls out tool number 2, which is this tool, I forgot you can't see the tools. When he calls out tool number 2, he gets this tool. And if a kid were to call out tool number 2 as that tool, do you see how there could be a little issue there? One's a lot longer than the other, we'd have big problems. So we want to make sure that all the tools are the same. And if you look carefully at this, the way I've got these lined up, let me see if I can, there we go. So we've got tool 1, 2, 3, 4, 5, 6, 7, 8. If you look at these, all odd number tools in the Project Lead the Way tool library are flat end mills, and all of the even number tools are ball end mills. Now, when you start out, you might not have all of these tools. These tool holders are pretty expensive. You might not have all of these tools. I would say that I could get by my first year with a 3/8 ball and 3/8 end and an 1/8" ball or end. With those 3 tools, I could do just about anything. Might take longer. My favorites, my go-to is the number 7. 1/2" end mill. That can hog out a lot of material pretty quickly. And if you notice, my tool number 7 is black. This is a solid carbide tool because when you cut wood, if you're going to cut wood, you cut with a router at very high speeds, very high RPMs. And if you don't, you see how this tool's black? It's not supposed to be. It's supposed to look like that. This one burnt. It gets burned. And then the wood burns and it gets smoky and your tool shot. You can never use it again. So I went and bought a solid carbide 1/2" end mill. This will last through my retirement because it's as long as the kid doesn't break it, it's solid carbide. It won't burn and it goes through wood like no tomorrow. It's awesome. And I have to be honest, I haven't had kids break a tool in quite a while either. So that's a good thing too. So to set up a tool, your tool library, if you take a look at what Ryan's showing you, I can do that. I've done this on my machine, and basically there's a button that says setting up your tool library. You have to go in, and I just did this today with my kids, and they opened up the picture of the tool library. And once they open up the picture of the tool library, they just go through, and I tell them we have tools 1 through 8. Put tools 1 through 8 into CNCmotion, and they use the setup library button like Ryan's showing you right now, and they go through and they type in the tool type, the description, and the diameter. Those are the only 3 things we really need in CNCmotion, because CNCmotion really is just our software for simulation. Those are really the only 3 things we need. You can type in the other stuff if you want, but you really don't need to. Those 3 things are the only ones you need. And once you've set up your library there, on the actual machine, you have to use what's called the Setup Tool Library Wizard. And there's a wizard that, what it is basically is it checks the height offsets. And Ryan's opening that right now. You'll see that that's under tools also. And this is really pretty straightforward. You go right through it step by step, and it tells you what to do. The one downside is that as you click through and read what you're supposed to do, and you do it, if you forget, and all of a sudden they're grayed out and you can't do the next step, it's because you have to hit the F5 button. If the bar up at the top, the information bar at the top of your screen turns yellow after you send the tool, after you insert the tool, that'll turn yellow saying, hey, are you ready to go? And you try to jog it and it won't jog. It's because that bar up top is yellow and you have to hit the F5 key. Just hit the F5 key. And basically what it has you do is it has you take every single tool in your tool library and put your tool into the machine. So for instance, I'm going to take a tool, I'm going to start with tool number 1, and I'm going to put tool number 1 into my machine. to put it into this machine, and I think the bench mill has the same one, if I remember correctly. You put, or it might have a pneumatic one as well. You put it in like so, and don't let it slam. There's a spring in here. If you just let go of this and let this slam over, it's going to break eventually. And the tool's in. Then what it'll ask you to do is it will ask you to bring this down to the table, and I use this special device, and it has you jog I can't do it with the thing open, but I put this right on my device, and I send the tool down and touch off on that button on the top, and that'll light up my red light. Then I go back to thousandth mode, and I back off my tool by thousandths until the light goes out. Once I do that, I say OK in the software, and the software remembers how tall this tool is. That's called the height offset. Then it asks me to put in, do you want to do other tools? And I say yes, and I go through and I put every single one of these tools into this, and I jog my machine, and I bring tool number 2 down, touch the button until the light comes on, and then back off by thousandths until the light goes off, and hit the OK button, and it remembers the height of tool number 2. And I have to do that for all my tools. And once I've done that for all my tools, I have to test it. And to test it, it's really pretty easy. This is called a height offset gauge, and you can get that from NCO/MSC. I think it's MSC. It's called MSC now, right, Ryan? That's right. And once you buy that, it lasts forever unless you punch a hole through the top of it. The kids will punch a hole through the top of it with this. The light bulbs are only $5, and basically it only breaks the light bulb. But to test your machine, to test your tool library, what I can do is on my software. Ryan, would you open up go to View and choose, when you open it up, I'll be able to tell you what it is. View absolute position. So once you get absolute position up on your screen, you can jog your machine, and I'm going to use the jog buttons. I'm clicking on my screen. Ryan will show you where the jog buttons are. I can jog my machine. I'm going to put it on continuous, and I'm going to jog my machine over to a piece of material that I have. I use styrofoam for this. A piece of builder styrofoam works wonderfully. You put a piece of builder styrofoam into it. I've got tool number 2. So if I look on the bottom of my screen, Ryan, if you point down at the bottom of your screen where you can see what tool number you have in it, tool number 2, I have tool number 2 in there. It says I have tool number 2. I can now bring that down by double clicking on the absolute position box and telling it to go to 0, tab 0, 1, which is Z of 1, which it's going to go to 1 inch above my piece of material. So if I hit go, my hand's on the red button too. And now it should be 1 inch above my material. What I can do is put this on step size of increments of tenths. And if I Z down, if it's Z of 1, and I Z down 2, 3, 4, 5, 6, 7, 8, 9, 10, it should be right on the top of my piece of stock. And I do that with every tool. I go up to Tools, and I say Select Tool.
Here. So I was trying to, hopefully people can see what I'm doing there on my screen.
Every one of my tools.
I'm just trying to point to where Chris has been talking about as we're going through there as best I can. Because without being connected directly to a machine, it's a little bit different, but I am pointing to the same spots he's talking about. The second thing is that in the chat window, Jed asked if we have to do that every time you use the machine. So you must home your machine every time you start it up. Like you've got to go through that homing process, but it will hold and remember your tool library as long as you don't make any changes to it.
Any questions?
If you break a bit and you got to replace that end mill or something, then you need to reestablish that tool offset.
About tool changes my first 2 years teaching sim that I did one tool operations all year long. I never, ever did a tool change because the first time I tried it, I broke 2 tools because I didn't set it up right. I don't know how I didn't set it up right, but kids helped because they broke a tool and then they just stuffed another tool in there without telling me, and it was the wrong height, and it was just a big fiasco. But once you do it once, you get the confidence that all your tools, you test it, you make sure it's set up right, you're good to go. And here's a tip too. When it asks you to set a reference height, what I do is I have a blank tool holder in my tool library. I happen to have a spare, and I use that as my reference height, okay? Because that will never break. If I use that tool as my reference height, this is the one that's going to break most often. And what happens, if I use this as my reference height, then if I break a tool, the only tool that I have to redo is the one that I broke. So if a student breaks this tool off, I have to take this one out, put a new one in, and now do you understand that that tool is now going to be a different height than this one? No matter how hard I try to get that exactly the right length, it's never going to be exactly the same. So I have to go through the tool setup wizard again for just that one tool. It'll ask me if I need a reference height, and I don't because I already have it all set. I just do that tool over again. So that's a great question. You only do that. I do this once a year at the beginning of the year before we do our flanges. And then it's good for the rest of the year until a kid breaks apart. I got to be honest with you. I don't ever let kids set up my tool library. I take the time to do that because too many things can go wrong. You know, you skip a step. It's near the end of the period. It's a Friday afternoon in America. You know, you want to get on with things. I always do that because I want to make sure that tool library is set up, and that never let them change their tool library. Like a kid will go into CNCmotion on their computer, and all of a sudden, oh, I meant to use the 1/2-inch end mill. So just for kicks, rather than to make it easier, they'll go into CNCmotion and change their tool library. You have to stress to them that they cannot change their tool library in CNCmotion. Go back and fix it in HSM, or go back and fix it. Don't go and change that because it's going to be different on this machine over here. There is a PowerPoint on tooling. There's a whole bunch of information on tooling that you want to know about tools. Should I be using two flute end mills? Should I be using 4 flute? Should I have center cutting? I don't ever buy anything that's not center cutting.
I mean, unless
they end up getting broken, and then you have to guess, what they can be used for. We've put together a PowerPoint.
Absolutely. And I have, depending on what type of machine you have, I've got some different tooling going on, but
it talks about all the different
have
kinds
some quick
of tools
change
and what they're good for.
collet holders as well, much like you would have with the Intellitek machines,
end mills,
and that makes
really
your life
good
a lot
for
easier. Tooling
pockets.
is fairly expensive, so you really want to double and triple check what you're doing.
Complex surfaces.
Chances are that you're only going to machine Ren or wood, or maybe some light plastics of some type. But even with that being said, like if you run into your vise, chances are you're going to snap the end mill off.
Here's a 2
and
flute
that could be $30–40 down the tube pretty quickly.
How many teeth or how many flutes?
You can find cheap end mills, I guess, to start out. Harbor Freight even sells some pretty inexpensive little sets of end mills just as you're playing around. And I really encourage
how many teeth are
people who are new to CNC machining to use the blue
So when you're
foam
doing any mathematics
or
with
some type of
tool speeds or
material that
feeds,
is almost
which
like
we can talk about
non-existent to the end mill,
later,
just
that's
until you
also
get your
in that
bearings with
PowerPoint
how
talking
things are
about
going to
how to
move,
calculate
how
speeds and
quickly
feeds.
things are going to happen, so that you
We'll be doing that. We're
know,
going
how
to
much
let right
time do I
now.
have
We're going
before I
to
need to hit this emergency
let
stop if
HSM
I don't
calculate
like
the
what's
speeds and
happening.
feeds for us.
The blue foam, it's as if
Anything
nothing
else,
is
Ryan?
there. It would be the same
About
thing as running
tools,
it in
or
air pretty much, but you do get some type
I
of result.
had to go
The
and
only
buy.
thing that I will tell you about wood
I had to buy extra
and the
holders.
blue foam that you can get at Lowe's and Home Depot and all those home improvement stores is that it will get all over your machine, and you need to clean that off because it'll pull the oil right out of the table, and it'll cause some problems like with the seals up and around the spindle. It'll cause you some problems if you don't take care of your equipment. So make sure that you are having your kids clean up, or however you want to handle that in your own classroom. That's up to you, but you've got to take care of stuff.
I always keep a can of WD-40, and after the kids use this for the day, my second class, they know to come over and just spray it down with WD-40 to keep this all oily, to stop. In the wren shape, really polyurethane foam too, that sucks the oil right out of the metal parts, causing some problem time. So you really want to stay on that. And when you're done using it, spray it down with WD-40 or some oil, some fine oil. They make special oils for it, but WD works just as well too. Because all these metal parts, and same if you take a look at my tool library, it's kind of
absolutely.
greasy,
and I have, just to echo what Chris is telling you, which is spot on. I have thousands, literally thousands of dollars worth of tools. And you don't want to have to replace that just because you're not taking care of things. So every time that I'm done with a tool and it comes out of that machine, I'm holding it in a shop towel of some sort, and I'm spraying that down with WD. And the last thing to touch it is the WD and that towel, not my hand, because my hand will leave residue on there, and that'll rust my tooling.
The idea. Yeah, and this is my burnt end mill. You want to stress too that you should never touch the flutes or the teeth on the end, because these are the cutting edges all the way down, and these are made for cutting steel. I have, and you probably can't see it real well. There it is, 7 stitches right there from this end mill. A kid went to grab his part, and it was right in front of his part. He went to grab his part, and I knocked his hand away before it hit the tool. That tool wasn't even spinning, and I ended up with 7 stitches and blood spurting everywhere. That was many, many years ago, back when I was young. So I don't want it happening again. I make kids in their program always put a safe position so that the tool ends up back here. And so I never let kids handle this end. And again, they're holding it by the tool holder, and like Ryan said, you're using an oily rag, grabbing it with an oily rag. You're not holding it onto it with your hands. Beautiful. I think if there aren't any other questions, I think we're just about almost ready to actually make something. But we have one more thing to do. So we've homed the machine, so the machine knows where the work envelope is. It knows it can only go this far, and how far up and down it can go. But it still doesn't know. It doesn't have eyes, so it doesn't know where this is in our machine. And right now, it thinks that 000 is right there, but it's not. I want 000 to be on the fixed corner of my part right there, because I programmed it in HSM so that positive Y is there, positive X is there, positive Z is there. So it should be on that corner right there. 2 ways to do this. I'm going to show you the ILAR method tonight, because one kid broke my edge finder, and I didn't have time to get a replacement here. So I put a link in the discussions to a video that we used. We were going to do a video for it, and then I watched one that Tormach did, And Tormach did this awesome video on how to use an edge finder. It's really just requires a little bit of math, and it's perfect. It's dead on every time for finding the corner when you want to do an accurate mass production of something. I would definitely use an edge finder. Since I'm doing one-off project tonight, I'm going to use the ILAR method. And basically what I'm going to do is I'm going to drive using the jog control on my computer screen. I'm going to drive my mill to that front corner. And as I go, I'm going to change the step size to smaller so that I can check my tool and try to get it right on the corner of the X and the Y. And yes, you machinists are cringing right now because ILAR, just so you know, stands for it looks about right. So I just use the it looks about right method to find more of my piece of stock. And once I find the corner of my piece of stock, and Ryan's got up on the screen right now the Tormach video of how to use an edge finder, and that method is much more accurate than what I just did. And basically, I buy the inexpensive Wiggler one, and as you touch the edge of your piece of material, it starts to wiggle. And if you know the thickness of the piece on the edge finder, you cut that in half, and you'll know what the x-axis is. And then you do the same thing on the y-axis, and you'll know what the y-axis is, and you type those two numbers in on your machine, and it works perfectly every time. They also make an electronic one. If you're really a fan of the electronic one, that video also gives a demo on how to use the electronic one as well. And that part of the video right there shows how it wiggles when it finally touches the edge. Those work really, really well, as long as you don't drive it the wrong way in X or Y and break that little piece off the end, which happened last week. But so here we are. We've got the tool set on the corner. Now, if you remember in CNCmotion, there's a send tool corner. That's basically what we just did. But then the one thing that you want to remember to do before you get going on this is if you look at my absolute position, if you could see my absolute position right here is not 0, 0, 0. So I need to go to the setup menu and choose 0 position. And always ask me, are you sure you want to make this 0 on all axes? Yes, I'm sure. So right now it thinks that that corner of my piece of material right there is 0, 0, 0. So now it knows where home is, it knows where its work envelope is, and it knows where the piece of stock is in the machine. And it's really ready to go. In terms of running the machine. Here's another place where kids will really mess up, or new teachers too. If you, I don't know how well you can see my screen, probably not very well, but when I go and I jog my tool over to the corner of the block, I need to check down here the machine information. This says tool 2. I need to check that against the tool that's in my machine and make sure that that's tool number 2. And if you look carefully, I've labeled all my tools with a paint marker so that a kid sees if the machine thinks it's tool number 4 and that says tool number 2, PRZ is wrong. And everything from that point on goes awry. So you really want to make sure that gets taken care of first, that the machine, the tool the machine thinks it has, and the tool that's actually in it actually match. And I set this up so I use tool number 2 to find PRZ. It doesn't matter what tool you use to find PRZ. when I use the ILAR method, I picked the smallest that I own because it's easier to find the center of it by eye on my Z-axis. It makes it easier that way. So I now have PRZ, and I should be ready to run my part. Notice though too, tool number 2, I don't start with tool number 2. And if you look at Ryan's screen, he's got the program that I'm about to run, and he's got the stock. And if you notice, like, whoa, stock's the wrong size. So a project we just did required a piece of stock that size. This stock that we need in this flange is 3 by 2. So if you double click on the screen, you can go to the stock panel, and you can change the length in X and the length in Y to the proper dimensions. And in this case, our X is 3, our Y is 2. And height's 1.5, but it really doesn't matter in terms of, because we're starting off the top of the block. So the height of the block actually doesn't matter, but for looks, if we want it to look right, we're all set and ready to go. So the kid comes over to this machine, and he's already verified it on his machine. So he comes over to the actual milling machine, and I make him verify it on the milling machine as well, so that he can look in that window and see that what I think is going to happen is really going to happen. In the verify window, it's just like the verify window in CNCmotion. It does the same thing. It asks for the tools, and you click on the green go button, and boom. Okay, so we know this is going to drill a hole first. And if you look at the code, you'll see that, yep, it's going to drill the holes first. It's remarked. And then you look up at the yellow. So the idea that by doing the verify is that they see what's going to happen before it actually happens. It's not a guess. It's a, geez, I don't know it first. Oh, it's going to do the holes first. Then it's going to do the pocket. And then lastly, obviously, it's going to ask for a different tool. And we got a change order from President Trump on this, and I'm using a ball end mill on this. So there's a ball end mill that goes in and does that slotting operation at the end, or the contour, depending on how you do it. And the estimated machine time on this, I think, is about 2 minutes and 21 seconds. I make them tell me what the estimated machine time is, so we have an idea of what it's going to be. And then once I verify it on the verify window, the kids can go ahead and run it. And to run it, it's really easy. Ryan can't, well, he could, but he's not hooked up to the machine. It's the run button, which is the green go button right next to the verify button. So if anybody have any questions before I actually start this machine up and see what happens? No, I think we're good to go. Okay. So I'm going to say green go on my screen and run program. First thing it's going to do is a tool change. The kids say, hey, wait, it's tool number 2. We don't need tool number 2. That's okay, because we wrote this program was to make sure that it asks us for a tool change before every operation. And because it asks us for a tool change, it says insert tool 3 now. So I can go in and remove tool 2 and put tool 3 in. One thing you want to be really careful of is to not hit this while I can do it now while it's not running, and then put it back and the red light goes away. But if this machine starts running and I accidentally hit this with, say, a vacuum, because the kids will go in and vacuum while it's running, when they do that, if they hit this while it's running, it stops in the middle ram. And the Super Pro light and the bench mill, when it has an e-stop by this getting triggered, or the e-stop button on the front of the machine getting triggered, either of those two things will send that machine to a state where it doesn't remember where home is, or PRZ. So if that emergency stop is hit, or you hit this open while the machine's running, you have to start this whole process over again, from homing machine to PRZ. Just a little heads up, okay? If you hit one of the saw stops, the red button here, or the red button here, or the red button here, it does not lose PRZ or home. Just a little known fact. I don't tell kids that because I don't want them to not hit this button. I would rather have to home it than replace a tool. So it says insert tool 3 now. I have to verify that it actually physically says tool 3 on the tool, and then it's ready to go. I think we can see this, and I think I'm going to move this into a better position. Let's try this. There we go. Tool number 3, insert tool 3 now, press go. My hand is on the red stop button. I used a regular old wrap it out. First thing the kids want to do is grab that stuff out there. Don't do it. I usually have a paintbrush over here that I use to pull that all off, or the kids will have vacuum running and suck out a vacuum. I don't have the vacuum running right now because I don't want the noise on the video. So now the screen's telling me at the top line of the screen, it says insert tool 7 now. So I put that away and I choose tool number 7. I check and make sure that it's tool number 7 that I'm putting in. I put tool number 7 in and I hit the green go button. I'm going to use the feed override on the right-hand side of my screen, and it's going to speed it up as it ramps into the part. And then finally, to insert tool number 2 now. I chose the tool number 2 ball mill, made the kids do a change order. The directions say to use a tool number 1, the end mill. I just made them change it up so that they know how to do it. And you hit the green go button. And it'll say normal program stop when it's done. If you take a look, you see I make the kids put a safe position in there at the end of every program. So there's a safe position that makes it go off to the side like that. I'm going to turn that on for a second. And voila, our piece is done. We'll set this back over here. And it took about 2 minutes to machine that. And you'll see that I ought to try to figure out a better way to do that, or maybe make more depth cuts because I packed that material in there. You know, I'm going to have to take something to get that out of there. But the parts all, and it did a 3-tool tool change, and everything worked out pretty well. And I could very easily take another one, make sure my parallels are in, make sure it's all cleaned out. And I could hit the green go button and I could make these all day long. If these were, this is how we do our container project. So we do any mass production. The kids will design one, and then we pick the one that the kids is that is the kid's favorite, and that's the one we mass produce. We don't have a real big milling machine. This is the only milling machine we have. We have this one and the other one just like it in the back of the room. So they're rather small. We can only do one up for most of the projects that we do. So we do the bottom side over here on this machine, and then we send them over to the other machine and do the top side. And we can knock out a whole class set in probably, depending on the part, in 3 or 4 class periods. That way they're learning the process, and while they're manufacturing them, they're sitting down at their desk making their individual parts. So everybody actually gets to make their individuals. The next project after the flange would be the container project, and Ryan showed you a bunch. I think we showed you a bunch of different ones. Here's some examples, and we showed you some online. Here's some from Cal Poly, one that somebody did at Cal Poly. So this is going to be the next project that we talk about and that we do. And here's a round one, a circular one with an index on it, so that it'll only go on one way and all the flutes stay lined up. Laser engraving on the top. Here's one. It looks like wood. This is wren shape. This is the wren shape material. This year they had to design a box that would hold a deck of cards. So this was the winner that year, and it had a fluting on it. And we also